Hey, with all this new AI related stuff, things are moving really fast, both on the outside and also with me. And I want to talk about a few nice ideas that I keep discovering, but I keep running out of time because I work on a few things. So I'll make a quick video and I want to talk about designing software. This one is a lot more crucial because one, we are creating code bases that have to be easy for humans to understand, but also it must be easy for AI to extend. And this particular thing that I want to talk about is related to the tool called Clarity, which I'm building right now. And I want to explain how this thing works, right? So if you look at this, it's a tool that parses files in a code base, and then it tells you how the design looks like, right? And usually when you have smaller components, and if you have these arrows flowing in one direction, that means your design is fairly good, right? Because smaller components easier to test, reason about, easier to maintain. And arrows moving in one direction means like the data flow is happening from one direction. So it's easy to reason about, right? You're not going back and forth. So the critical thing that I want to talk about here is Sanity is a tool that supports parsing multiple languages. At this point, it supports about 14 languages. And I want to say why that is part of this conversation. In the initial days, it was a very small POC. I came back after a couple of months and I was looking into a code base, mostly AI generated code. And I was trying to reason about one part of the code base. And at that time, I was not able to understand what was going on because it was all AI generated. So I took a piece of paper and then started drawing all of these files. And then I manually looked into the IDE and figured out how they were related to one another. And that's how I came up with this idea of a simplified dependency graph that shows only files. Now, um, with Sanity, initially, it supported only two languages, like it supported Dart, some support for Golang. So these are the only two languages that were supported. And when you're working on a software system, usually based on the requirements, the system tends to grow in one particular direction. And it's usually useful for the business. And in this case, if Sanity is a tool that is generating dependency graphs from programming languages, obviously you need to support a lot of different languages. Now, this is a design that the AI created. It created a dependency graph, and then the dependency graph was talking to the Dart parser and the Go parser. And it looks simple, but when you look at it, why does the dependency graph talk to language parsers? Like that doesn't make sense, right? And what happens if I want to add support for more languages? Then do you keep adding more arrows from dependency graph to other programming languages? That also doesn't make sense. So at least when I was presented with this, I had some fear because I did not know how I would go about adding new languages without introducing bugs. And I also asked myself if I would be comfortable accepting contribution from external developers or someone else who's not working, who's not me. Right? At this point, I was the only one who had enough context about the code base. And in times like these, that fear is something um, is a good signal. So what I did was I still use Sanity, and then I started asking the tool questions like, "Hey, why is this dependent on the two? Right? Like, why is it dependent on the Dart parser? Why is it dependent on this Go parser? Don't you think there should be some level of abstraction between the two, which would make dependency graph work with all languages, but it doesn't have to know about language specific implementations?" Now, the way how I went about this was mostly asking the large language model to generate diagrams using Clarity, the open source tool. So the tool itself was generating the structure about itself. So I was using Clarity to build Clarity. And based on the answers it gave me, I would tell it to do stuff. Like, say, for example, in this case, I would say, "Hey, can you introduce an abstraction between the dependency graph and the parsers, right? And then it would go ahead and then like introduce a abstraction. So eventually you do this enough number of times, and eventually you start to understand the solution domain, right? Because you're trying to explore a domain that you've never explored before. And eventually you come up with a design. It took me a couple of days to just like talk about design. I was not actually looking at the code. I was mostly looking into the diagrams. And then I would keep asking a lot of questions to the LLM, and based on the answers, I would give it certain directions. And at one point in time, I become quite comfortable with the design. I was like happy with the design. So this is how it looks like, right? Initially, if you look at it, there was a dependency graph and it was like talking to the parsers, the Go and Dart parser. But eventually, the kind of design that I arrived at looked like this, right? So this was a point where I had refactored the code using the large language model and Clarity, and I added support for one language. And once I was quite happy with having support for one language, then I thought like, hey, let's just try to push it even more. And this was one commit where I was trying to add 4 different parsers. Now, if you look at this again, the arrows are flowing in one direction, right? So all of them are flowing from left to right. And each of these have like very specific responsibilities. Like say, for example, there is a language registry, which sits between whatever is generating the graph and other programming languages. You have a C module, you have a parser test for the parser. Then you have a dependency resolver for C, and then you also have a test file, which identifies like whether a given file is a test file in the code base, right? Now the thing is, this is about symmetry. Now, when you're looking at these, almost everything follows the same pattern, right? LLMs are really good with pattern recognition and replication. So that is sort of comforting because I don't really have to go review the code base. At least like I can just look at these diagrams and then say if something is right. So if someone is going to contribute to my code base, then I can look at this and then say, yeah, that looks right, right? And what happens when you have a design like this is that when you're making changes to the system, you can specifically tag these smaller components in your chat conversation. So your conversation becomes a lot more precise. Instead, if you had all this functionality in one file, then it's going to be challenging for you to like convey what you want to the language model, right? So in terms of structure, this is quite good because it gets things done. But if you have a question, hey, okay, this all looks good on paper, but does it work? That's another interesting question. It doesn't work immediately. So what I do is like once I add support for this, then I run each of these parsers against real code bases. These are like not random code bases. These are like popular open source projects that are already available. And the way how I verify the support is actually a skill in the repository. So if you want to say, okay, like now you've added support for C++, how do you know it works? There is a verify language skill that I've added. It's a sequence of steps that actually picks up random commits from third-party code bases, and then there is a workflow that you can look at the skill. So one part is, at least at this point, I'm like not worried about if someone is going to add support for new languages, because if I'm reviewing their PR, I just have to look for one of these patterns. And if they have this pattern, then I can be pretty confident that they've gotten it right. And the second thing is I would have expected them to run the skill for the particular language. So if you add support for C#, then I would have asked you to go run the verification skill. And if you run through the verification skill, then I know like it works because you would have captured enough tests from external code bases. Yeah. So the point that I'm trying to make is earlier when we were building software, design was not very visible. So you could get away with bad design for a very long time because bad design also like happened over a period of time, and creating code was also very slow. With large language models, you need to be able to create code bases that you can understand as a developer, but you should also make it easier for other developers to contribute to your code base, other agents or whatever tool that you're using to contribute to your code base. So design has become a lot more crucial, and we have never had design feedback, right? Like even when you're reviewing code, there is no way for us to review design easily. But now with Clarity, obviously you can do that pretty easily. And this one has now become a fairly large code base. It's about 20,000 lines of code, and it's grown within like 3-4 weeks of contribution, which is pretty significant. LLMs are doing most of this heavy lifting, but then for me to have a tool like Clarity and then guide the direction of the large language model has proven to be super helpful. And the fact that I don't know Go, I've never written Golang. I probably have written like one project in Golang a long time ago. But I really am not a Go person. Like have a Java Kotlin background. But just by looking at the dependency graph, you can abstract away all these language specific dependencies. So that's what I want to talk about software design a little bit. And yeah, I should also show you Clarity. So this is Clarity. This is the tool that I'm using, and I built it because I couldn't understand a code base that I wrote like a couple of months ago, but now I use it for development, code reviews. I essentially use it for all parts of my software development stuff. Try this out, and if you want to know how I use it, or if you have any questions, I'm more than happy to answer. All right, thanks for watching. See you around.